Hi everyone, and welcome to Mod 3 of MA 215, Applied Statistics at Bellevue University. This week our focus is on what happens when we have two quantitative variables. So when we have two quantitative variables, the easiest way to display those is in a scatter plot. And what's important to understand about a scatter plot is that each of these points on our scatter plot represents the same individual. So essentially, we're measuring the same individual and two quantitative variables about that individual. Therefore, we can see if there is a pattern between those two variables. The two variables are called the explanatory variable and the response variable. So essentially what we're saying is that X can somehow explain what's happening to Y. Now that doesn't mean it causes Y, but that we can see that there is some sort of relationship. So the explanatory variable attempts to explain what's happening on the Y-axis. The response variable is what we're measuring to see if whatever changes in X happened affected Y. So let's take a look at a couple of those together. Gina is seeing if students with high U.S. history grades also have high chemistry grades, and she finds no relationship between the two. So we have two quantitative variables. We have U.S. history grades and we have chemistry grades. So we need to choose which one is explanatory and which one is response. Well, we know that Gina already knows that these students have high U.S. history grades. So that's going to be our explanatory variable, which of course is our X. And remember, the X always goes here on the X-axis, and the Y always goes here. So what would go on the Y-axis? Then the chemistry grades. Finding that there's no relationship between the two, we'll talk about what that means in just a little bit. And next, Corey wanted to see if the amount of time spent reading your statistics book would give people a higher grade on their Unit 1 test. So amount of time, of course, is quantitative because we're talking about a length of time. That's going to be our X because people are reading to see if it makes a difference on their Unit 1 test grade, which again is also quantitative. So X, explanatory would be time reading stats book, test grade would be your response. Do these three on your own and then press play to check your work. So the first, we have baseball teams that score more runs also sell more tickets. So again, we already know that the baseball team is scoring more runs. That's going to be our X. Selling more tickets would be Y. So number of tickets would be Y. Do students with higher SAT scores get better grades? Again, the higher SAT score, so the SAT score would be my X, which is my explanatory. The grades that they get would be Y, which is the response. And can we estimate a person's body mass index by measuring their wrist size? So again, this one, be careful because they don't give it to you in the correct order. We're saying, can we estimate a BMI by measuring their wrist size? So we're going to measure their wrist size and see if that has some effect on their BMI. So that is the response. Now, when we talk about scatter plots, there are three main things. There's direction, and the direction basically tells us, are they positively associated, meaning as one goes up, the other goes up. And the easiest way to remember this is that, of course, if I were to draw a line, it would have a positive slope. Are they negatively associated? So as one increases, the other decreases. And again, if I drew a line, it would have a negative slope. Or is there no association? So looking at this scatter plot, it doesn't really look like there is a relationship, so that would be no association. So when we describe a scatter plot, first thing we talk about is the direction, positive, negative, or no association. Then we have the form. So the form is either linear, and of course that's what we're going to focus on in this section, is when it actually is linear. But obviously that only accounts for, a small portion. So it could be that it's curved, like this. We can see if we were to draw a line of best fit, it would look more curved than straight. Quite often, if we have something that's exponential or quadratic, as we have here, we may be able to straighten it with a transformation, which we'll talk about more this week. And then it could be that you have clusters. So here it looks like I've got a couple of clusters of data. or you have curves up and down, so that would be something that would look more like this or opposite. Those are difficult to straighten, so those it's just really hard to do any sort of analysis on. So we've got direction, we have form, and then of course we have strength. So the strength, if it's, you know, all pretty clear that it's all going positive in the right direction, that's strong. This would be moderate. I can still see that there's a positive association here, but notice it's not as tightly clustered around that best fit line that I would draw. So this is a moderate association. No association, again, would be that you just have a bunch of dots and there's really no association that we can come up with. And of course, we need to then talk about anything that's out of the ordinary. So this is a scatter plot where we clearly have one piece of data that doesn't really fit in. Those are called outliers. So it stands away from the rest of the overall data. And it's always important, if you're drawing a scatter plot, for you to talk about the fact that there is an outlier. And we'll of course talk more about how we do that later. So looking at this one, and I already have the answer uncovered here, but let's talk about the association on this. So remember, we're looking for direction, strength, and form. So to me, the direction is positive, because if I were going to draw a line, it would go in the positive direction. I would say it's moderately strong, because it's not tightly clustered, but it's still pretty clear there's a linear pattern. So I have a moderately strong positive linear association. So again, I drew a straight line. And then this part's very important. So here I said the cost of women's clothing and the cost of food, so women's clothing and food, have a moderately strong positive linear association. So that's all of those: strength, form, and direction. And then I say what that means in the context. So I'm saying higher clothes costs. So as the X variable increases, what's happening to Y? The Y variable is increasing. So higher clothes costs correspond to higher food costs. I would like for you to do the same here. We're looking at a graph of the hourly average wage versus hours to earn an iPod. So go ahead and press pause, describe this association, and then press play to check your work. So looking at this graph, if I were to draw a line, it would be a curved line. That was not very good, but you get the idea. In addition, as I go from left to right, it's decreasing instead of increasing. They are pretty tightly packed together, however. So I would say in terms of strength, it's a strong, and I would say curved association. Again, we're looking for direction, strength, and form. So the direction, of course, is negative. The strength is that it's very strong, and the form is that it's curved. So the average hourly wage and the hours needed to earn an iPod have a strong, negative, nonlinear, or you could say curved association. Higher average hourly wages, so as X is increasing, what's happening to this? You have fewer hours needed to earn an iPod, which of course makes sense.